Okay, this video is going to be a little different from some of the other ones. We are going to look at the first part of dealing with the Tower of Hanoi puzzle. Please make sure you have looked at the video on recursion or read the textbook about the Tower of Hanoi problem before you look at the rest of this video. I do want you to realize I've gone to a great expense to make sure that we could have a physical copy of the Tower of Hanoi. Okay, I guess I don't have all 64 of the golden discs, but I have enough of them here that I think you can get the idea of how this works. We want to look at how the number of discs that we have compares to the number of moves that it takes, and see if we can make a pattern. Now, you all should have read about the Tower of Hanoi and know what the rules are for this. You know that the goal is to move the disc from this first pin to this one, but you always have to leave the disc on top of a disc that is of a larger size. Well, when we have just one disc, it's very easy to move it over because it only takes one move. We just move this thing one time. Now, when we go to having two discs, like this, in order for me to move the blue disc to the last position, I move the red one to here first, then I can move the blue one over, and then I can move the red one to here. So you see, it's going to take 3 moves. But I'm going to write it this way because we want to start seeing the pattern. When I add a third disc, well, for me to move the green disc to here, I first have to move the other 2 discs to here. The way for me to do that is to do the pattern I did before. Do 1, 2, 3. Then I can move this one, and then 1, 2, 3. So it took 3 moves to get all of the discs off of the top of the green one. 1 move to move it, and then 3 moves to move them back on top for a total of 7. I know it's kind of hard to write at this angle, but we'll see how it goes. When I go to 4 discs, in order to move the light green one to here, what I need to do, oops, I moved it, sorry. In order to move that light green one to here, I need to move these 3 to this position. For that to work, I have to do what I did before, so you see it's going to take 7 moves. Then I can move the bright green one, and then it'll take 7 more moves. You see, it's based upon the case before that. So, what I have is 7 plus 7 is 14 plus 1. It takes 15 moves to do this. Let's do one more. Alright, to move the blue one to here, these 4 need to come to the center. And that's the problem we just did. You see, that's going to take 15 moves. Then I can move the blue one. That's 1 more. And then finally I can move all of these over to here. That's 15 more. So this is 31. By now you should see that part of the pattern that goes with this, here in the center, crudely written. We'll look at it in a little better light in a minute, or in the next video actually. What you should be able to see is when I did this, we're always basing two of the entries here on how many moves it took the previous time. So, this is the basis of how the Tower of Hanoi works, and we're going to look at the mathematics behind it next.